Everyone to go to page number 3. We are going to be working on our notes for topic 2.1 and 2.2, all about reasoning, visual reasoning, and inductive reasoning. Make sure that you pause the video where you need to. By the end of this, your notes should look exactly like mine. So if you don't have the notes packet, please take this time right now to go to the classroom work wall. Make sure that you have the 2.1 and 2.2 notes. They are linked on It's Learning, and they are also printed out in class, ready to go. Double check that it's not in your book bag somewhere before you go get one of the other copies. Last time we talked about when you make a guess, when noticing a pattern, it's got a special name. It's called a conjecture. When you're noticing and using patterns and reacting in the world, you are using conjectures, and those are all a part of inductive reasoning. Making generalizations, reacting to the world, that's using our inductive reasoning. When we talked last, we were looking at different patterns of numbers. If you were given the pattern, let's say 1, 3, 5, 7, 9, you can probably guess what the next number is. Whether it's because you think that the pattern is I'm only working with odd numbers, or you could also think about it as you're adding 2 each time. When you are making a guess based on a pattern, test out some theories. If it does not work, we just try it again. So when you are making a guess, it's a conjecture. If it is true, then you are using your inductive reasoning and you found our right answer. Let's try it out with a rule that maybe we feel comfortable with because it's algebra based. We have a rule from Joel. His rule is 3n minus 2, where n is your place in the pattern. Okay, so in the first place, the very first term, I would plug in the number 1. 3 times 1 is 3, minus 2 is 1. We would slowly start to be able to find the second term, the third term, the fourth term, fifth term, etc. So in my little workspace area, I've shown what it looks like when I plug in the number 2. 3 times 2 is 6, minus 2 would give me 4. So in the second spot, I should have the number 4. Plug in the number 3 for the third spot, or the third term. Pops out the number 7. In that little workspace, you can see where I'm plugging it in using those parentheses. Please make sure that you do include a workspace. For your final answer, make sure that you recognize what that 1, 2, 3, 4, 5 does. It's showing where it is in the lineup. So in the first spot, my answer is 1. Second spot, 4. Third spot, 7. Fourth spot, 10. Fifth spot, 13. The nice part about Joel's pattern is maybe there's something else that I recognize now. Looks like another way he could have shared his pattern in words is he could say, I start with the number 1, then I add 3 to get the next term. Him giving his pattern as an algebraic expression, though, allows me to know where to start since he didn't give me the first term in the very beginning. With inductive reasoning, we can also use our visuals. Take the time to draw out the next shapes. In A, just draw the first one. It does get a little messy with how many branches end up happening. I'm visualizing a tree. If I were trying to describe the pattern that's happening in A, is I notice that at the end of every tree branch, when it moves to the next spot or term, it slowly is getting 2 more branches off every single branch. Okay, but not at the bottom. So make sure that it's just focused on the top pieces. And then in B, I notice that we start with 1 dot, then there's 2 dots, then there's 3 dots, then there's 4. And they're connecting all the dots in as many ways as possible. Here's one way to say what's happening in that second pattern. For that second pattern, we add a vertice and then connect all of the diagonals. So in the first spot, there's no other vertice to connect, so we're just having one dot. With 2 dots, we connect them, that's a line segment. 3 dots make a triangle. 4 dots, we got a quadrilateral. And make sure that you're connecting across the way. In the next one, it looks like I'm missing one. How would you improve that? I need to add one more. It looks like I missed a diagonal. Let's add that in there right now. So we need to connect these 2 vertices. So it almost looks like it's got a little star on the inside. That looks a lot better. And then in the last one, it's kind of messy, but one easy way to check is that every single vertice has 3 lines coming off of it. Looks like I missed another one. Let's add it in there. So it looks like we need to add one more vertice, make it a little bit more dark to show it up. Does look all connected. Okay, that looks so much better. So we have a star on the inside. This one looks a lot more detailed, a little bit more crazy, but try to connect all of the diagonals. Let's scooch on over to example 5. What is the pattern that you see below? Sketch what should go in the middle to complete the pattern. Well, looking at it, every single row and column, that's another thing to notice. Every row and column has 1, 2, 3, 1, 2, 3 shapes showing up. So in that middle column, I have 1, blank, 2. Looks like I'm going to need 3 of something. I also see that the rows are all the same shape. So it looks like the middle row is going to need 3 ovals. So 3 ovals are missing in the middle. Another thing in our picture is that some of them are shaded in, some of them are not shaded. Try to draw out what you think would end up happening in that middle. Feel free to pause. In mine, I had 3 filled in ovals. So I noticed that each row had the counting of 1, 2, 3 of all the same shape. Each row had 2 of them filled, 1 unfilled. With the columns, if you were using the columns, which is the up and down, I would have noticed that we have 2 unfilled and 1 filled. Okay. So the middle one needs to have all ovals because that's the middle row, and it needs to have them all filled in so that it does complete that pattern for us. Let's look at some numbers. It is math class. We have to play with some numbers, of course. We're going to consider this pattern of 8, 4, 2, 1. There's a couple different ways that we can actually work with this. So what do you think is going to be the next number in the pattern? What does your gut tell you? Do you notice that maybe it is divided by the same number every time, adding the same number every time, subtracting? What do you think? And can you figure out another way to think about this pattern? Because I told you there's more than one way. The first pattern that my brain sees is that every time we go to the next number, it's being divided by 2. You can also say multiplying by 1/2. You're still going to get 1/2 as my next number in the pattern. But what if that wasn't the pattern? What if it continued and just kind of repeated the same 8, 4, 2, 1 over? So it just said 8, 4, 2, 1, back to 8, 4, 2, 1. That would mean 8 would be our next number in the sequence. What if it just went in reverse? So it would go 8, 4, 2, 1, then it would go back to 2, 4, 8, 4, 2, 1. It would just keep repeating that pattern back and forth in reverse. So those are 2 different ways that you can see a pattern. If it was on a test or quiz, I would expect the 1/2 to show up because I don't see any of that repeating with the given information. So I would say 1/2 is our best answer, but 8 and 2, if you want to debate with me, I think it could work. Okay, we got our last one. Mallory is training for a marathon. She ran for 15 minutes on the first day, 19 minutes on the second day, 23 minutes on the third day, 27 minutes on the fourth day. She continued in this pattern of increasing her run by the same amount every time. How long did she run on the 30th day? So you have to think way far in the future. This is a really good one to use that algebraic functions like Joelle did at the very beginning. With this type of question, they want you to think so far in the future that you want to be able to plug in any number that you want. So